2018 Calc AB free response question number 6 has a FRQ in it. Part A is actually one of the easiest things that it can ask us to do. It gives us a slope field and it asks for you to sketch a solution curve that passes through the point 0,2. Okay, I don't know if you guys noticed, but they put the point 0,2, they put a polka dot there. Okay, and I'm going to try to draft the solution curve that goes through this point by following the flow of the field. If I go off to the right, it looks like I should go straight, and if I go off to the left, it looks like I should go off straight. It is okay to have a linear solution curve. A line is a type of curve. Okay, the second point was the point 1,0, and the point 1,0 is here. Now on this one, I'm getting swept up this way, and then I'm getting swept down this way, only to get swept back up this way. Okay, and it doesn't have to be perfect, it just has to follow the general flow of the field. Okay, and there are my two solution curves. Okay, B asks us to write an equation for a tangent line. Right, there's two things I need to write the equation of a tangent line. The first thing I need is a point. So I'm given the point 1,0. The second thing I need is my slope. So my slope at the point 1,0, well, I'm going to plug into this little slope equation here, and I'm going to have 1/3 times 1 times 0 minus 2 quantity squared. And I get 4/3 that way. And the equation of the tangent line is then y equals m times x minus x1 plus y1 plus 0. I don't have to write. And then I'm going to approximate f of 0.7. And the beauty in not having to simplify my answers is that I could say that f of 0.7 is approximately 4/3 times 0.7 minus 1 and just leave the answer just like that. Okay, so find the equation of the tangent line. I need my point and my slope. The slope I get by plugging into the differential equation. And then I'm writing y equals I'm writing y equals m times x minus x1 plus y1. And then at the end, plugging in the little x that they're asking me to plug in without simplifying it. Finally, for part C, it asks me to solve the differential equation. Of this differential equation, I'm going to start with separation of variables. Okay, I'm going to bring over as little as possible with that y, so I'm going to make it 1 over y minus 2 squared dy equals 1/3 x dx. Okay, remember for AP, you get 1 point just for doing separation of variables. Okay, so just for getting the y's with the dy's and the x's with the dx's, you get 1 point. Now I'm going to go ahead and integrate both sides. The right side is easy enough. Hold the 1/3. The antiderivative of x is x squared over 2, so I get x squared over 6 plus c. You're going to get 1 point just for having that constant of integration right there. This integral of 1 over y minus 2 quantity squared technically needs a u substitution. If I let u equal y minus 2, du is just dy, so there's no coefficient change, but what I have is the integral of u to the -2nd du, which is I'm going to increase the exponent by 1 and divide by nu. If I put that back in terms of, well, let me just rewrite it here, it's -1 over u. So if I put that back in terms of y, I have -1 over y minus 2. I don't really need those parentheses. Okay, all right, I'm going to get rid of the negative. I'm going to make it 1 over y minus 2 equals -x squared over 6 plus c. And I'm going to solve with my initial condition right now. My effort to plug in this point, this coordinate 1,0, is enough to earn me an additional point. Just plugging in this point, even if my solution so far is wrong, even if I don't plug in this point successfully, my effort to plug in the point is what I need in order to earn a single point on this test. So just the fact that I put in a 1 for an x and a 0 for a y gets me a point. Now I'm going to solve this. I have negative 1/2 equals negative 1/6 plus c. That's going to get me c is equal to, that's negative 3/6 plus 1/6 is negative 2/6, or negative 1/3. Okay, so I'm going to have 1 over y minus 2 equals negative x squared over 6 minus 1/3. Okay, you might want to make this a single fraction here. You have a lot of options for how you solve this, but it might help you if you say, okay, let's make the whole thing over 6, and then it would be negative x squared minus 2. And then the fact that I have fractions on both sides, I can flip both fractions, and I can get y minus 2 equals, the reciprocal of that one is 6 over negative x squared minus 2. And then I'm just going to add the 2 to the other side and get 6 over negative x squared minus 2 plus 2. Now this might not be the exact answer that AP has on their scoring guide. I'm willing to bet that it's not the exact answer, that they're going to have tweaked it a little bit, but it's certainly an equivalent answer, and it's the easiest version of it. If you did not like the finding the common denominator here that I did, another option would have been to, to cross multiply, and I could have cross multiplied once I did find that, so that's kind of what I did. I had 1 times 6 is 6 equals y minus 2 times negative x squared minus 2. And then I divided both sides by this negative x squared minus 2. And that's why flipping both sides seemed to work. It's really cross multiplication and then doing division. But that got me to this point as well. So just another way to look at it algebraically. All right. If you guys have any problem solving a DiffEQ, you need to bring it to my attention. I need to be able to help you through it at this point.